Okay. Welcome everyone. So, yeah, today is usual Sunday. It's not 20 p.m. unfortunately. Oh, sorry, just 20:00 Prague time because I'm a bit late because I'm not in the office as you can see today. So yeah, for those who are who have just joined, yeah, I'm Microsoft engineer. Software engineer at Microsoft, and today we are streaming. For the past 3 months, I'm trying to get back in terms of my skill. What do I mean particularly is the skill for LeetCode and system design. So yeah, usually we are doing streams from the Microsoft office regularly on Sundays, 8 p.m. Prague time, but yeah, today I decided to do it from my home and not from my Windows machine but from Mac. Let's see how it goes. Let's compare actually the performance and quality of the stream comparing to the Windows machine, because yeah, it might be actually better, and maybe I will switch to Mac completely during the streaming, which is quite possible. So yeah, today what we're gonna do, today we're gonna solve a couple of problems on LeetCode related to graphs and dynamic programming. One of the problems was asked during previous streams, so yep, we're gonna do it. Okay, so far let's see how it goes. Let me just check some technical stuff and we're gonna start. Let me just check chat. Good. Seems like working. So yes, working. Good. So yeah, the plan for today. Last time we stopped at the number of provinces. We solved this. And today we're gonna start with this particular problem. Actually, one more thing that I would like to share, that actually lately I switched to Python from JavaScript. For the past 2 years I was solving all LeetCode problems only and exclusively with the JS. Only in rare cases when I needed priority queue I was switching to C#. So yeah, don't judge my Python skill that much, because yeah, I don't use it that long at the moment, so yeah, I'm not that good at it. Also, I might GPT some of the Python questions, for example, what is the syntax for this and that. Also, what we're gonna use Visual Studio Code, because it has vMotions, which is much better for me personally. Because vMotions is it's very great thing. Good. Interesting thing that we just started streaming and we have completely 0 people, and I don't understand why so. But hopefully people will join later. Anyway, okay, let's do this. So what is the first problem that we're gonna have? This is a graph problem. The problem states the following. We should reorder routes to make all paths lead to the city 0. There are n cities, numbered from 0 to n-1, and roads such that there is only one way to travel between 2 different cities. Last year the Ministry of Transport decided blah blah blah. Roads represented by connections, this is just H, represents the road from city A to city B. Anyway, this year there will be a big event in the capital city, city 0, and many people want to travel to this city. Your task consists of ordering some roads such that each city can visit the city 0. Return the minimum number of edges changed. It is guaranteed that each city can reach city 0 after reorder. So, yeah. Oh, sorry. I don't understand why. Yeah, I think this is a bit broken at the moment, because somehow I see that there are actual people on the YouTube, but my Restream chat shows me 0 people watching right now, but I can see in the YouTube there are 3 people watching right now, so I don't know. Yeah, okay, anyway. I'm afraid that I can just miss some messages or some, yeah. Okay, good. So let's get back. Yeah, I hope I will not miss. I will be just checking the web clients, and then that will be it. That will be it. Good. So yes. So we are given the graph. One thing which is important about this graph, that this graph is 3, which means this is DAG, which is directed acyclic graph. What it means that this graph cannot have cycles, which simplifies us task quite a lot, because well, yeah, that simplifies us the things quite a lot, because if we have cycle, the algorithm might be much more complicated than it is. So yeah, it's stated, I remember there is, yeah, this network format 3, which means that there is only one root rooted at 0. It might have multiple children, they cannot have cycle, and this is directed graph, which means if there is direction from 0 to 1, for example, from city 0 to city 1, there is no direction from city 1 to city 0, right? So what should be actually the algorithm? Let me actually try to draw a bit. Exactly. So we see that there are, in this particular case, that there is, oh yeah, beautiful. What is our task? Our task is to make city 0 reachable from any other city. It means that whatever city I pick up, let's say 4, I can travel from 4 to 0, which is actually true. But for example, in this case, if I pick city 2 or city 3 or city 1, in all of these cases, I cannot travel to city 0, because from city 3 and from city 1, there is no connection to the city 0. So our task is actually to reverse the order, reverse the direction of the edge. Basically what we're gonna do right now, and let me just check, should we return the number of swapped, or yeah, so this is the number of reordered edges in our graph. So in this case, we clearly see that there is no way from city 1 to city 0, so we need to swap, to rotate the edge, reorder it, so this is already 1. We see exactly the same problem with city 3, because there is no way to get from city 3 to city 0. That's why we change the order of the edge as well, count +1, and it's all good with the city. From city 2 to city 3 we can reach right now, like that. Good, now we check in city 0 and city 4, it's all good, there is nh. And again, there is problem with city5 because there is no way from city5 to 4 and consequently to 0. That's why we are changing the order of the edge, counting +1. So our answer is 3, and this is exactly the answer in the our question. So this is all good. This is all good. Now, what should be our algorithm? Basically, we can actually start from the city 0, and before that we need to build the graph in some way, right? Because in order to traverse and to solve tasks that are related to graphs, we need first to get this graph done, because right now we have just array of edges, which is not that much useful, especially in terms of complexity, to look up these things. So how are we gonna build the graph? In this case, if we build directed graph, it will not help us that much, because let's say we are building this graph, and if we build it in the way it is, there is only path from node 0 to node 1 and to node 3. And this will be our directed graph. Or maybe no. Yeah, this will be like one graph, and then there will be another graph. Let me change the color. This one, and the third one, this one. Which means it's hard to connect them, because whenever you have directed graph, at some point, if we start from node 0, let's say, and we want to traverse this graph, it means that we cannot, let's say, go from node 0 to node 4, because there is no edge connecting to that. It means that if we cannot go there, we cannot traverse and check this guy, for example, and this specific edge exactly needs change in the order. Which means we actually can build undirected graph, so we can reach every single node starting from 0. But also we might keep another copy of directed graph just for the purpose of checking what is the direction of the edge. Is it from the source to from our source city to some other cities, or is it vice versa? If there is no edge vice versa, so meaning we are keep investigating our single node, and if we see that there is no edge from adjacent node to our current node, it means we should count this node this edge, because it needs to be changed in terms of direction. So this is exactly what we're gonna do. In terms of algos, it means that we are building the graph, and we're gonna do depth first search, just traversing from this 0 city all the way down, checking whether there is direction which fits our needs, and then we're gonna optimize it a bit. So let's basically start. So first of all, we need our undirected graph. Let's name it undirected. It's gonna be adjacency list representation, and let's just traverse our connections, and connections in our case are just edges. So connections, and if you're not in undirected, then basically we're gonna add it. I think we can just have set. Same thing happens with another node. And then after that, since it's undirected, what we just do, what we just do after that is adding the connection between them. So there is connection between U and V, and since it's undirected, there is connection between V and U. So this is undirected graph, but unfortunately will not be enough, because let's say we just have these connections right now. So let me maybe do a bit too much. Yeah, like that. So we have undirected connections between the nodes, and we don't know which one to reverse, right? Because from undirected perspective, any city can reach the root city in our case. So for that purpose, we also build in directed graph as well, which will be represented by these dark arrows. So that's why I'm putting here directed. But directed graph will be pointing only the actual connections that are between the cities. So how it's gonna be? We also want to check, yeah, if there is not indirected. Actually, we could use the default dict structure, but let's do it in the real way, so it is applied for other languages as well. So directed U equals new set. And also we want there is connection between U and V, and then we also adding V just to have it in graph, because this node actually does exist in our graph, so we want just to add it. So if we not indirected, then we just add indirected V new set, but set will be actually empty in our case. Yes, at the moment. So we will optimize it later to having only one graph. This is just for purpose of demonstration, right? So now what we want to do, we want to create some DFS. Let's first create recursive one. Later on we can optimize it to iterative, no problem at all with this. So let's do it. It's gonna be gonna have some visited. But actually, I think visited might not be even needed, since it's 3 and directed acyclic graph. But let's see it. Let's see. So visited from the beginning, it should have the node itself, which is in our case we start with city 0, right? Is it 0 indexed, right? Yes. And now we are doing basic DFS. So yeah, what we do, we go through each adjacent node in our undirected, because we want to reach everything. And what we do per this node, we just check. There is also gonna be reversed count equals 0. This guy is gonna be, or what is it in? I think this is the right way of doing it, I'm not sure. So for every adjacent city which we're gonna explore, so we start from 0, we start exploring city 1 and city 4. If there is no connection vice versa, so there is no connection from adjacent node to the node, which is our current node, and how we're gonna check it, we're gonna just check directed graph adjacent, and yeah, if our current node not indirected, then in that case we're increasing count. So let's check it again. We are checking adjacent node. Let's say adjacent node in our case can be 1. Our current node is going to be 0. We're checking whether our directed graph in the node adjacent, which is 1, has adjacent node, which is 0. Basically what we are checking that there is connection like that. There is no connection in directed graph like that, so we increase in count. We start in like count plus plus. Then in case we're checking node 4, which is going to be our adjacent, and this is our current node, there is in directed graph node in adjacency list of adjacent node, because there is this connection, so we don't increase the count. And that's basically it where I am. Yeah, so then we increase. Yeah, and in general algo we're also gonna visit, but I'm not sure it's needed since it's dark. I don't think it's actually needed, but maybe it is if there are no cycles. I don't know. Let's just first do it, and then if so, we can optimize and remove it completely. So if adjacent not in visited, then yeah, visited at adjacent, increasing count, and then performing DFS on adjacent. Yeah, basically it should be it. It should be it, I guess. Then what we're gonna do, we're gonna call DFS on 0 and then return reverse count. That's gonna be it. Okay, let's just do basic sanity check. So reverse count is 0. We're starting from 0. There is undirected 1 and 4. Let's say we start with 1. We're adding it, visited to that. It's not in visited. We're adding. Oh, then adjacent list. Yeah, we do need visited, because otherwise whenever we move to node 1 we can start exploring node 0 backwards, so we need kinda check it. Exactly. Let's check whether it works or not. Yeah, I'm sorry. I'm new to Python, sorry. Yeah, it works. Let's just check. We're gonna draw complexity and then improve it very fast. Okay, so for now, yeah, no commands, we are not missing anything. Yeah, let's see, maybe this is due to I stopped the stream just a couple of minutes ago, and that's why YouTube doesn't want to promote the stream, I don't know. But anyway, so yeah, this is our performance. What about the time complexity? So our n is actually the number of cities or number of edges. Yeah, number of cities. So actually in our case, n is going to be a number of vertices, and connections is edges, are edges. In that case, so while building graph, we are checking every single connection, and these are considered constants. So let's say time complexity is of, let's say the connections, okay, let's name this guy as vertices v, and this we're gonna name as e, so it's O of e. Then we are doing DFS, which gonna traverse all the nodes and traverse all the connections. So it's gonna be O V plus E. So basically, this guy, which is simplified to this guy. Worst case, regarding the space complexity, well, we have graph where we store everything, right? So it's also O V plus E, and also we have additional stack, a visited map, which in the end is gonna be just the all vertices that we have, which is this one. And since constants are not included, we just remove constants, and this is our time complexity. But now let's improve the solution a bit. We actually don't need two graphs. We only need the representation whether the node that we are, or sorry, the edge that we are investigating, is it right one or it is the one we need to reverse. And how we can represent it, there are a bunch of ways. You can use numbers, you can use booleans, you can use whatever you want. So let's change it. So instead of two graphs, we're gonna have only one graph. Let me get back to our solution. Only one graph. This thing I'm gonna just remove. And now we are checking if u not in graph, then graph u equals new map, because now we are not just interested in the adjacent node, but also about the value of the edge. So in this case, we're gonna have some weight between the nodes in their edge. And this weight is going to be represented by the Boolean value true, whereas true means that the connection is right, so it means the connection is from adjacency back to the source node, and false if it's not right and we need to change it. Yes, so if we not in graph, we also gonna do that. Graph v, sorry. Okay. And now, how are we gonna do it? So graph u and v, it's no. Or let's maybe represent Boolean flag in the following way. If it's true, this is the real connection. If it's false, it's just our additional connection that we just used to simplify the algo, basically. So this is the true connection, and vice versa, it's superficial connection, so it's going to be false. So in this case, right now, what is happening, we have our graph, and we have, let's say, node 0 and node 1. So from 0 to 1, we have true connection. From 1 to 0, we have false connection, which means not the real one, and it's legit the true, that it's not real one. And now we're gonna just do same DFS traversal, and if there is if we used true connection from the source to the target, it means we need to increase count. Exactly. So visited, we still, I believe, need visited. Reverse count also we need, blah blah blah, it's okay. If it's not in visited, and visited add, yeah. And now this guy should be a graph. And now what we check, if graph node adjacent is true, which means there is connection between the source node to the target node, which we should reverse. In this case, we just increase reverse count by 1 and call DFS again. Right. Seems reasonable to me. Let's check it. Hey, hey. Hello for all new people. Yeah, stream is going very bad. So, yeah, it works. And this is how I just simplified to one graph. And now it beats like 90% exactly. Time complexity is exactly the same, it's just a bit more optimized, and then that's it. Actually, DFS can be transferred and changed from recursive to iterative one, but I don't think we need it. If you want to see it, also ping me in chat, but I don't think we're gonna see any messages about this. So with this one we are done. Now we are moving to very interesting problem, quite interesting problem, which is pretty hard to actually solve. So in the first glance, I wouldn't say it's a graph problem at all in general. And also, if you go to comment section, it's also quite interesting to see because, yeah, medium, are you kidding, lol. How on the earth the number of provinces problem and this monster have the same medium difficulty level. So you can see, guys, basically people are not that, you know, happy with the medium level of this problem. And also I wasn't happy as well back then. So let's read it and solve it step by step. We are given variable pairs equations and an array of real numbers values where equations I equals AB and values represent the equation A divided by B equals values I. Each A or B is a string that represents a single variable. Okay. Also given queries represents query where you must find answer for C divided by D. Return the answer to all queries. If a single answer cannot be determined, return -1. Not the input is always valid, so bunch of, you know, these two notes you should actually get from your interviewer by clarification questions. The input is always valid. You may assume that evaluating the queries will not result in division by 0 and that there is no contradiction. Okay. Okay. So let me rephrase it in a bit simpler way. I hope it is simpler to you. So we have equations. Let's say, actually let's get it straight away to our, no, this is not what I wanted to do. Let's get it straight to our Escalidraw and I will draw you examples so you'll understand it pretty fast. Because sometimes, yeah, LeetCode is hard to grasp straight away. So we have a bunch of equations. What it actually means, okay, we have variable A and we have variable B and they are divided and the result of division is the same indexed result in the values, which is 2.0. Then we're iterating to the next index. We have variable B and C. So B divided by C is equal 3.0. And that's it. This is our input from which we should kind of do something internally, blah, blah, blah. And then there are queries which are asking us to return what should be the value from variable something to variable something. So in this case, what it's gonna be the division A divided by C. So this is not something that is given us in the input right now. And this is exactly the problem, that now you should basically apply the general mass to conclude what would be A divided by C. So let's basically try it. So we have A divided by B equals to 2, and we have B divided by C equals 3. And now, like, what we can do in this case, we can, for example, say that I don't know, express something through another variable. So let's say, I don't know, let's do this one, b equals 3 times c, and then what we are doing, we just putting this b into this equation, and we have a divided by 3c equals 2, and a equals to 6c. So now we are removing c out, so a divided by c equals 6. This is the answer to our question, to our query, this guy, and this is exactly the proper answer. Hello, how do you learn system design? Could you suggest what to start from? Yeah, sure. So the main starter is this book. I read it, I don't know, maybe 5-7 times overall during my career, and before actually every single important interview I was reading this book, I mean rereading it. So Martin Klapman must have, this is the first book you should start with. Then you have lectures by Martin Klapman. Yes, Klapman. Yeah, this guy. So you should watch everything here for system design. And then what you do, you just go and Google general system design questions that you want to do, right? And in the end, you just try to build it on your own and then check YouTube, the resources, ChatGPT, what is their solution, compare pros and cons, what you built, what they built, learning something, and this is how you approach the system design interview. Okay, so let's get back to our stuff. Well, what you actually should conclude from that is that, that A to C, like this is the way how we can go from one variable to third variable by transitivity. So let's say we have A, B, and C, and we want somehow to know what it be to go from A to C. And this is going to be 6 by the mass equations, general stuff. Oh, sorry, you cannot see that stuff, I guess. Maybe move it a bit. Yes, I think now should be bad. Oh, sorry. Exactly, yeah, like that. So now let's use some, I don't know, heuristics, like some induction, some fundamental stuff to understand what is it. Right now, maybe you could already have some intuition that this is basically a graph problem, because the variables are the nodes, and what is asked in our case is how to get from variable left variable to variable right variable in our queries, and give the answer for this. So let's say we have this input. How we can build the graph, like having this input data. So we know for sure that going from A to B takes us 2. From B to C takes us 3. And we kind of know that from A to C it's gonna take us 6. Which is actually, if you try hard and try from like different perspectives with different variables, different values, you would understand that actually what is happening here, that whenever we go in somewhere, we just multiply the value that we already got to the value that we are using for as an edge. So let's say the value we already have is 2. We are on B right now. We have value 2 because it's multiplied by 2 equals 2. And now we're gonna traverse from B to C, which is gonna be 2 multiplied 3 equals 6. So it means it takes us basically 6 as a weight to get from A to C. Now the interesting question. In the query there should be B to A. Yes, B to A. What is the weight and cost of going from B to A? And this is interesting stuff, because in the answer, in the example, they say it's 1 divided by 2. How come? So let's try to use our math again. So we know that a divided by b is equal to 2. Now, what it should be if we basically reverse I don't know the English name for this and that guy, but what will happen if we just reverse the number? So in a nutshell, the base and fundamental math tells us that this is correct. Sorry, so that's why what is happening, what is also going to be correct, b divided by a going to be exactly the same like 1 divided by 2. So we can safely put here 1 divided by 2. And this is exactly the base graph that we're going to build and start with. So let's say we have a and b, and we have basically 2 connections, and it is already enough for us to connect them individually. So instead of 3, it's going to be 1 divided by 3. And we already kind of have different paths to go, and now what we just only need to do is to traverse and find the target node. So let's say we are given node A in the query, and we want to find the node C as a target. What we start doing, we start in the A, and we are doing basic DFS by applying the multiplication of whatever we already have to the current weight of the edge, basically, and then that's it. And once we reach the target C, it's the answer. The current value is the answer. If the nodes that are in query are not in the graph even, let's say x and x, it's not represented in our input, so we don't care basically, then we just return -1. Because if we cannot reach somehow or whatever, we return just default value, which is -1. So let's now start implementing. This is pretty hard stuff to come up with, I understand. I was doing the math first time I saw this problem. I was doing this kind of math and for quite a long time before I come up with this graph representation of the problem, basically. But yeah, this is the math, and now with LeetCode and for interviews you actually do need the math. Let's start building our graph, basically. So we're gonna be, we're gonna go back here and check whether we are doing it correct. So we have our equations and the values. So let's first in range equations, it's gonna be len. Yeah, also let me go to my Vim motion stuff. Yes, so we traversing from 0 to length of equation, and basically our, I don't know, x is going to be, x and y is going to be equations I, and the value, which is going to be basically weight, is going to be values I. Now, we're gonna build the graph and put the connection between it. So exactly here we have node A, we have node B. Connection from A to B gonna be 2. Connection from B to A is gonna be 1 divided by 2. This is exactly what we're gonna do right now, and how we're gonna represent it in the moment. So if x not in graph, we're gonna just add it. Graph x new, and then graph x, and from x to y is going to be weight, and we're doing vice versa. If y not in graph, then graph y equals new. Yx is going to be 1 divided by weight. Good. This is it. It is as simple as that. Right now we built our graph exactly how it's asked us in the problem. And after that, what we're gonna do, we're gonna define our DFS function. So for DFS, we have our current node, we have visited set to not go same way again. We have our target node, and we have current value that we aggregated. So these are all weights that we have multiplied during our traversal. And we basically gonna start. So if can we go? No, it's not possible, I guess. So first, the base case, if not equals to target, which means we already reached our target, we're just gonna return value, which is accumulated weight. Now, if not in visited, we basically return -1. After that, we're adding it to visited. Good, and now we're gonna traverse it in a DFS way. So adjacent node in graph node. In Python, I guess adjacent node gonna be just key. And now, if adjacent node in visited, no, actually we don't care about visited at the moment because we did it up. So for adjacent, and now what we should do, well, yeah, I guess it's gonna be just adjacent target and value. Also, let's do and get the weight, and the weight gonna be node from the node to adjacent. So it's gonna be value times weight and visited. And what we're gonna do, sub answer, I don't know, if sub answer not equal to -1, then we return this sub answer. We don't proceed anymore because it means we found the target. If all of them are -1, at some point for loop will be over and we just return -1. We couldn't find the target node from our given node here. Okay, our DFS is done. Now we're gonna just go, The interesting point is that we have a bunch of queries, so we should do this DFS per each query. So what we do is source target in queries, sorry. Yeah, and we're just defining, also there should be some array answers, we should return the answer, right? Yes. And now what is going to happen, answer append, and we call this DFS for source target. I don't know how it will handle the naming, so let's just use shortcuts. Don't do this in your production code, it's a very bad approach. So source target value gonna be 1 because it's safe to use for multiplication. And now visited, for visit we just define a new set. And after all of this, we just return answer. Okay, seems like that's it. Let's actually check whether it works. Invalid syntax, what do you mean? Yeah. Yeah, also quite important thing here. I'm sorry. Oh, shit. How in the Mac to do undo? Delete and delete. Fuck it, okay, I will do it here. So quite important thing that I missed, that in the query we might have unexistent nodes that are not in the graph. For these guys, what we do, if src not in graph or target not in graph, then we just answer append -1 straight away, else we perform our basic DFS. This should be it. Yes, now it passed. Great, now time complexity analysis. So for building the graph, let first me define, okay, so let me define in a basic graph, I would say, theoretical background. So we have number of vertices, which is number of nodes, and we have number of edges. So in terms of these guys, in our case, the number of edges is the number of unique variables. Oh, sorry, number of vertices. And number of edges is basically number of array items. So lengths of equations. First, for building the graph, we are using default O of v plus e for sure. And then what else? For DFS, since we're gonna traverse it, in worst case, the DFS traverses whole graph, right? So every single DFS is v plus e, exactly. Also, we have number of queries. In worst case, they're all valid. So in the worst case, we're gonna basically do DFS number of times of queries. So let me define the number of queries as k. I don't know. So in this case, the algorithm complexity gonna be k times v plus e. For the space complexity, this is gonna be time. Yes, and for space complexity, we're building our graph, which is going to be v plus e. Visited in worst case v plus e, so 2 multiplexer is going to be just discarded, as this is big O notation. And these guys, an answer, I don't think it's counted, but the answer will be the number of the k, the number of queries, which is going to be, maybe let's add it as a k, I don't know. If we count output as a space complexity, if we don't, then it's v plus e. Okay, let me check the chat as well. The stream doesn't display for me. Oh fuck. Unfortunately, this is what I was afraid, because it happened to me, but then after restart it kinda helped. Ah shit. Do you know what I see right now? I will show you. Fuck OBS, like legit fuck it. Because this is what is shown right now in my live channel. Maybe this is exactly what is shown on YouTube as well, and that's why we don't have any people who are watching us. Oh my god. Thank you, Solaris, for letting me know. But I don't know how to fix it. I mean, I have OBS running like... I don't know. It literally says I'm streaming, right? Yeah. But as stream is showing me that I'm streaming and it's alright. There are 3 people watching on YouTube at the moment. I don't know, but YouTube at least works. Right, at least for me. I don't know whether it legit works or not. So unfortunately, yes, maybe up until I solve the issues, you would need to go to YouTube. I don't know. I tried it once and it was exactly this thing. I don't know why it works like that. This is very strange. But sorry, I can't do anything about this. I can just paste the link to YouTube. and that would be it. Thank you for letting me know. Fuck my life. I don't know, like, on which end this issue is happening. Is it OBS, Restream, Twitch? Because right, apparently on YouTube it works well. I have no idea. Anyway, okay. So let's solve one more problem. One more problem here that, yeah, this is the cool problem, which is basically kind of shorter sparse BFS problem. So nearest exit from entrance in maze. We have start point, which is where this character is located right now. We have some obstacles, and we basically cannot go in the direction of obstacles. We can go only to the up, bottom, right, and left. So we have some empty squares, and we can go to these squares, and it is allowed. Our goal is to, I think, count how many moves we need to go out of this map or whatever it is, and going out means that our character is on the edge of the map, so basically on the first row, last row, first column, or last column. Yeah, so let me just double check. With empty cells represented as dots and walls represented as plus. We are also given the entrance of the maze, where entrance equals entrance. Cool. You can move up, down, left, right. You cannot step into cell with a wall, and you cannot step outside the maze. Your goal is to find the nearest exit from the entrance, and exit is defined as an empty cell. Yeah, nearest exit. Yeah, nearest cell or the border of maze. The entrance does not count as an exit. Good. Return the number of steps in the shortest path from the entrance to the nearest exit. So how we're gonna do this? So in this particular case, we don't actually need to build any graphs, which is good. In this case, what we should do right now is we're gonna reuse our maze itself. So let me paste it to my perfect. Yeah, exactly. So we have some entrance, and this is our point. We can move only up, bottom, left, and right, and we should find the nearest exit. So basically, no matter where we are, what we want to do actually is to start from our point to explore in the circular manner all possible ways. Then for these possible ways, we're gonna explore all of the possible ways after their ways. And this is gonna continue like that, and the first time we're approaching the exit, we're gonna basically return the number of moves. This is somehow called level-based BFS or something like that. I will show you right now actually how it's going to be implemented. So we're gonna have, should we do it with the, no, BFS, we're gonna do it with Q. So we have our visited, let's actually not use visited, we can reuse the maze itself. So maze entrance 0 and oh my god, entrance 1, we are straight away setting it to visited, because it is already stated if entrance is already on the exit, it's not counted. This is just the starting point. Good. And now, now we are initializing our queue whatever. And in this queue, what we are putting our initial row and column where we are, which is entrance 0 and entrance 1. This is our starting point. From where do we start? And now what we are doing, let me also put levels 0. While this queue is not empty, we have our row and column. The current one is queue pop left. But also quite important stuff is length, or I don't know, maybe size, let's name it, is length of our queue. And we're gonna do it size number of times. I will explain later why so. This is level based BFS. So we got our current row and column, and now what is going to happen? Yeah, we try to go all possible ways. Right. Yes, so for delta x, sorry, delta row and delta column, maybe a bit shorter, dr, and delta column in, and which directions we can go. So apparently we can go up, which is going to be 1 0, so +1 to column and +1 to row and 0 to column. Then we're gonna go right, which is 0 1, bottom, which is up, actually gonna be -1. Bottom is gonna be 1 0, and to the left it's 0 -1. New r is gonna be r plus dr. New column gonna be column plus the column. And now interesting part, if new r less than 0 or new r more than, let's also define for convenience, this is just for convenience, much easier to write. If it's more or equal of n, or new column less than 0, or new column more than or equal of m, just gonna continue. So these are out of map positions. We're not gonna traverse them because we're gonna get out of range exception or whatever it is in Python, right? Next step, if maze new r new column is not equal to dot, which means the empty cell that we can go to. In this case, what we are doing is we are actually gonna go there. So we are doing q append, and we are appending ur and uc. Also, what is going to happen here is that if r equals to n-1, or r equals to 0, or c equals m-1, or c equals 0, then we return the number of levels. Otherwise, we're gonna return somewhere here -1. Right, yes. Yeah, and after this guy, Exactly. So, yeah, we try to traverse every single possible direction. We are doing it the number of our queue entries we have, and meanwhile we're still adding the new entries for the next round, kinda. This algo is used, also can be used in the shortest path for BFS. Yes. Yeah, and also what I forgot, that here we should add maze new add new C equals to visited. Yeah, basically that's it. Let me actually first get it running. It's not actually running well. Okay, so let me check what can go wrong here. Okay, this is interesting. This actually should work. Okay. Okay, interesting. Still the same. So yeah, I guess it should be actually checked here. Okay, interesting. Yeah, actually should be +1, I guess. Yes. So let's try. Yeah, a bunch of some bugs. Yeah, it works on the test cases. So how it works? Let me first explain it. So we're using entrance and we're using a level-based BFS or breadth first search. In other words, so this might be a bit strange thing for you, which is like, why do we do this? Why do we do it only for only size times? So we're only performing queue pop left, which is the queue in the item from the queue, size number of times. And then we are moving and performing it again and again and again. Why so? Why not just this? Because, let me draw you the explanation basically. Yeah. Set to clipboard. So now assume that we basically have everything here. Oh, no. Everything here free, and we are starting somewhere, let's say here. And also let me add some more squares. It will be much easier to explain with more. Like that and like this. Pam, 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 pam. So let's say I'm starting here, or even let's say I'm starting when this character started already. So yeah, this guy would be good. So I'm starting here. This is my character, and now my BFS, what it is doing. I'm getting size will be 1, and I will do this only one time. So I'm starting here, number of steps equals 0, and I go this direction, this direction, this direction, and this direction. This is yeah, what is going on in our BFS. So I'm starting exploring, and these 4 squares are added to my queue. And after I added all of them, I'm doing my steps equals to previous +1, which is going to be 1. Or it's not, it's levels. Okay, it's not steps but levels. Now I start exploring these 4 guys. And in this case, what I can explore, and let me draw now with the green one. I can explore this, 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 that, this, and this. All of these guys gonna be explored again, but we're gonna do it how many times? We're gonna explore these, then these 3 green squares are added to queue, then we're exploring next one, these 3 are added to queue. Well, this one will not be because it's already added. Now I'm exploring this square. I'm adding also 3 new squares to be explored, and this, the bottom one. And in the end, once I did it, I will do it only 4 times. If I do it 5th time, I will start with the newly added green square, which I don't want because I want to keep track how many steps I did. So once I finish with the blue ones, I'm adding 1 to previous number of levels or steps, which is going to be 2. So by the time I'm exploring these squares, I know I already did 2 steps. And if this one is the end, I'm doing 2 + 1, and it is the number of steps I need to do in order to find the exit. This is how I do it. So we're kind of exploring level by levels, imitating the number of steps by the circle of which we are exploring. Visually, it can be represented like this. So unfortunately I see there is not a big online on the stream. I don't know why, so maybe it's due to I'm streaming from the Mac, maybe it's some technical issues. I don't know, somehow Twitch doesn't work. I have no idea why and what happened to Twitch. It's just I don't know, I will even save this. It's just static picture over there, I don't know why. For YouTube seems like working, but maybe actually it doesn't work. You will never know, right? You will never know, especially with the fact that there are not that many viewers on the YouTube currently. So I'm afraid that streaming might not work as expected. So I think unfortunately due to this reason we should stop at that moment. Next time I will be with my Windows machine, maybe it will be better, but yeah, it was some experimental stream, just, you know, to solve our problems. And yeah, try on Mac, try Python, something new. Next stream I think I will have some updates for you guys, pretty important updates there might be, or at least interesting news. That what I would say. So right now I think, yeah, we're gonna stop here because Twitch doesn't work. I'm sorry. So thank you for all of you who were with me. Thank you to all of you guys, and it was me, Andriy, and see you basically next time. Bye bye.